All right, today we're going to look at scatter plots and trend lines. So a scatter plot is a graph that relates two different sets of data and displays them as an ordered pair, right? So I have three kind of types of scatter plot correlations that we'll talk about. So if I look at the first one, all right, I kind of look and I say, well, it's kind of going upwards as I go left to right. So here I have a positive correlation. Here I'm kind of seeing that I go downwards, so I have a negative correlation. And then here I look at this last one and say, well, there isn't really anything going on there, right? Nothing that's kind of trending upward or trending downward. So this one is no correlation. Okay. So making a scatter plot is pretty straightforward, right? It's looking at and saying, okay, if I'm given kind of my X and Y, right? How are they related? So I'm just graphing these, right? So X is going to be my altitude. And Y is going to be my temperature. All right, so I kind of start here at 0, and my altitudes go up to 5,000, right? So look and say, what's going to be a good graph, right? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 4, 5, 6, 7, 8, 9. So I have 10 kind of data points. So I'm just going to make this kind of go up by 500s, right? So I kind of label that. And I might have to kind of extend my scatter plot just a little bit. And temperature, right, it's kind of going from 0, almost 0 to 60, right? And so I kind of have 10 lines again. So I might go 10 every line, right? And then I'm just plotting these points, right? So 0, it's about 59 degrees. At 500, we're a little bit warmer, right? It's kind of about the same. 1,000, you get a little bit above 60. Oh, that's why that's wrong. Hold on. Just notice that kind of my scale is a little bit off. There we go. So 500, right, did 1,000 feet. I'm at 61, so I get a little bit higher. And at 1,500 feet, I start kind of dropping again. Here, 2,000, dropping some more. All right, 2,500, I go down to 29 degrees. And I keep kind of plotting these points. And sometimes I might just have to estimate kind of where I'm at, and that's okay. And then 5,000, get down here. So look and say, well, what type of relationship does it show? Well, right, if I look, for the most part, things are kind of going down as I go up. So this is going to have a negative correlation. So one thing that I can do is I can say, okay, I can kind of take my scatter plots and start looking at what I call a trend line, right? So a trend line is a line on the scatter plot that kind of draws kind of through, kind of trying to hit as many points as I can, and that's going to help me kind of take my correlation and figure out other values, right? Because I only know distinct points, so what if I wanted to find something I didn't know? I have ways of doing that once I find an equation. So I look at two different things, right? First one is interpolation, right? So this is when I estimate a value that's between two things I already know. And then I can also do extrapolation, which is predicting a value kind of outside my range. So let's look at kind of finding a trend line and estimating something. So this first I need to make a scatter plot of this data below, right? So I have my kind of age and weights. So look at my ages down here on the x-axis and my weight over here, right? So I can say I have 1 and I might go up by 2s. Right, so I have enough pot. And then I look at my weights and I'm kind of going from 2.5 to 54. So if I go up by, let's just say 5 every time, I should hit most of my points. Then I just plot these, right? So at 1, I'm 2.5 pounds. 2, I'm 7.5, so I'm kind of looking here. 3, I'm at 12.5. 4, end up at 17. 6, 20, almost 25. All right. 8, I jump up to just about 40. 10, I'm up just about 50. And at 12, I'm kind of up here off the graph, right? So if I'm going to talk about finding the trend line here, I'm looking for what kind of line goes through as many of these points and does that. So I have a couple ways of doing it. I'll show you how I can do it on, kind of writing the equation myself, and then we'll talk about how we use the calculator, and that's what we'll really stick to. So a good trend line here is going to be one that kind of comes and hits a couple points and has kind of the same amount of points on each side, right? So here I'm hitting a couple. I've got 2 points kind of on the top, 2 points on the bottom of that line. So I'm going to look at how do I find the trend line. So if I look at this, right, what I'm going to use is kind of my data points as 2 ordered pairs, right? And so I can use the first and the last one, as kind of my ordered pairs, and I want to find my slope, right? And then look at and say, how can I do this? All right, so my slope, remember, is going to be that 54.9 minus 2.5 and 12 minus 1. So if I do that, all right, 54.9 minus 2.5 divided by 11, I'm going to get 4.76. And because I'm not going to be graphing, I'm just going to leave that as a decimal. Right? So I have y, and let's just say I have y minus 2.5 equals 4.76 times x minus 1. And let's just solve that for y, right? So I'd have y equals 4.76x, and then, okay, what is 4.76 plus 2.5? So you get plus 7.26. And so if I look and say, well, I want to know what is the 7th month old, right? So I'm going to take and I'm going to plug in 7 for x, right? And say 4.76 times 7 plus 7.26. And so when I do that, I get approximately 40.5 pounds. And so if I look at 7 months, right, my trend line maybe isn't the greatest, right? I should have been maybe a little more steep in the one that I drew, but I can say, yeah, 40-ish pounds, seems a little bit maybe high on our data, but that's kind of what happens when I write equations. And so that's why we're going to really focus on using a calculator, right? And so the trend line that shows the most accurate is going to be called the line of best fit, right? And that's why the calculator is going to do it for us, because the computer and the calculator can really handle that. And then it's going to give you kind of this correlation value that tells us kind of how closely the equation models the data. So if I look at this, right, and I have kind of this this table here, right, and I'm going to look at what is the kind of relationship between the cost and that, and then I'm going to look at predicting for the 2012-2013 year. So I'm going to look, and this is going to be kind of my X and my Y, right? Costs are numbers that are fine. Here, we can just call this 1, 2, 3, and kind of label that. So when you go to your calculator, when you turn it on, first thing you're going to do is go to you're just going to click Stat, right? So kind of go to Stat on the calculator. Second thing you'll do is you'll hit Enter on the Edit thing. Line 1, so that L1 is your X's, L2 is your Y's. So I'm just going to plug those in, right? So 1 through 7, and then the values for Y, right? 3508, 3766, 4098, and kind of keep that going. And so once you have that, then you're going to go and enter those, and you're going to go back to Stat, then arrow over to Calculate, and then what you're going to do is you're going to click the number 4. And so what that's going to bring up is a linear regression kind of thing in the calculator, so most of that you don't really care about, right? So you're just going to hit Enter to get to Calculate, and then that's going to do that, right? So Enter down to the Calculate, and that gives you your line of best fit. So then I just kind of write that equation out. So I have Y equals, right, and I look at my A values, so that 409.42x plus the B, right, 3001. It looks like these new calculators don't give us the R value, so I'm not going to worry about that. So if I want to find the prediction, right, I want to say, well, what is the Y value? So 409.42 times, and then I look at what's my X value going to be, right? So 6, 7 was number 7. So if that trend continues, right, that X value that I set up is going to be 13. And so here, I just want to use the calculator and say, well, what is 409.42 times 13 plus 3001? And then I'm just going to round that up and say, well, 8323 would kind of be my prediction. Okay, so anytime it asks for a line of best fit, just use the calculator, right? It's going to give you a much more accurate number than you would do, and it's a lot simpler and easier to kind of do it that way. So the last thing is something that we also kind of look at, and this is called causation, right? So causation is when a change in one quantity causes a change in the second, right? Things might be correlated, but they might not be a causal thing, right? So if I look at a couple examples, right, number of loaves of bread baked and the amount of flour used, I want to know, is there likely to be a correlation, and is it going to be causal, right? So I look here is, when I use more flour, am I going to bake more bread, right? So that's going to be yes, right? Positive correlation. And there's going to be causation here. Right. Second one, right? Number of mailboxes and the number of firefighters, right? This one, I look and say, well, does more mailboxes necessarily mean more firefighters, right? Not always. So, this one, right, there might be a correlation here, right? But, so I'd say, yeah, probably going to be a correlation. Not mailboxes, what am I doing? So I would say there's probably a positive correlation here, right? But it's not necessarily going to be a cause. Think about a community might decide to hire more firefighters, even if they don't, like their mailboxes didn't increase. There's various different things that are going to cause that. So I don't know that it's kind of a causal relationship.